In this video, we'll explore function transformations. Now, every function has a parent function, which is where we start from. F of x equals x, f of x equals x squared, the cube root of x. All of those, there's nothing else being added, subtracted, multiplied, or divided to that x value in the original function. And from there, we start to do our shifts. If we substitute in for x, the x minus h, we know that our graph is going to shift h units. If our function is added by some number, that's going to shift our graph vertically by that number being added. If we make our entire function become negative, we reflect the function over the x-axis, whereas if we substitute in a negative x into our function, that's going to reflect it along the y-axis. So let's look at some of these with an example. Say we have f of x equals x cubed. That is the parent function. Nothing's being added, subtracted, multiplied, or divided to that function. So say now we want to do x cubed plus 4. So we're taking our function and adding 4 to it. In this case, that means we're going to shift vertically 4 units. And we do literally what the number shows. So it's going to go up 4. If we look at, say, another transformation, where instead of doing x, we do the quantity x minus 2, that x minus h aspect. Now in this case, we're going to shift it horizontally because it's a substitution in for x. So we have the graphing going up vertically for 4 units because of the plus 4, and then here we've got the x minus h, so it's minus the specific value, in this case is positive 2 units. So it's going to also shift 2 to the right. Now the last type of transformation we could go about is plugging in a negative x. So say I put a negative x minus 2. So then x is now negative as well. So it still shifts up 4. You could start by shifting it to the right 2 units. And now, after you've done those two, the horizontal and the vertical shift, with that negative you can do your reflection. In this case, the negative is only being substituted in for x, so that's a y-axis reflection. So if we look at it here, the dotted line is where it was with just the shift of the vertical and horizontal, and you can see when it's reflected along the y-axis for that negative x that it is exactly reflected there, so that where it was shifted right 2 before, now it's shifted to the left 2, and you can follow that through all the points.